Let's start with a small anecdote. Luckily, I'm here at 8 o'clock in the evening speaking to you. Normally, if I wouldn't have checked my agenda or the event page, I would have been here at 6 o'clock in the morning. My boss had put in my agenda, like, hey Christophe, you have to go give a presentation at 6 o'clock. He misread the email of Philippe that he thought it was at 6 o'clock in the morning, which he found actually strange, but he said, okay, let's send a junior in. But yeah, I was like, okay, I'm gonna do it. And so last night at 12 o'clock, I just checked the event page, and then I just quickly scroll to the end and I see, there's also a New Year's drink at 9 o'clock in the morning. How can that be? And I said, okay, 21 hour, okay, yeah, fine. So I'm glad that it was not in the morning, but that I'm here. Yeah, thank you for inviting me. I will share my story, the story of Futureproofed actually. I've been working with Futureproofed since 2 years now. So Futureproofed is an international eco-consulting company. And we might be the only company actually striving to run out of business. Before we run out of a planet, of course. As you all know, we cannot have business on a dead planet. So that's actually our mission. Our mission is climate change. That's also the bottom line of our business is CO2. So what I'm gonna talk about now, 4 points actually. I'm just gonna raise the issue of climate change again, and hopefully the non-believers in the room, at the end of the presentation, I will have convinced you, hopefully. Second, I'm just gonna go through the different scenarios, because we have multiple choices. Doing nothing is also a choice, as you know. Then I want to introduce you to how we calculate emission inventories. Like I already said, our bottom line is CO2. So we actually calculate carbon footprints for big companies, but also for governments like Antwerp, Mechelen, European Parliament. And that's like the climate data part. And I'm also gonna just shed some small light on big data. We are taking very few baby steps now in big data. So let's say we are not the expert yet in big data, but it's something we are looking into now with the advent of Internet of Things and big data. So we see that we have to make faster decisions, so we have to make use of all these data we are sitting on. I have to put this from my boss, so just some commercial. So we are not only focusing on better brand, we are not taking our green paint to offices of companies and the European Parliament to paint the walls green. No, we are actually always talking about business. For us, carbon dioxide is actually waste. It's the waste of energy, it's the waste of resources, and that's actually what we want to tackle. This waste, it seems logical, there's a lot of money in this waste. No, we want to retrieve it, recycle it, make a closed loop out of it, and then at the end, you will also benefit from it financially. These are the companies and governments we have worked for. So you see also City of Antwerp, you see some big companies, Coca-Cola, Ecover, DEME. DEME, we organized a huge innovation conference now in December last year to actually identify the key priorities for DEME in the future, which key issues are going to raise because of climate change, and how can we actually turn those risks into opportunities. So that's also what we do. Like I said, it's about taking options. Not choosing is also an option. You cannot talk about climate change without talking about oil. And many people think that as we are working in the business of environment, ecology, that we are against oil. And no, it's not that. It's not that we branded by ExxonMobil or that we are sponsored, but we have to agree that everything is oil. The way you came here, your cereal breakfast this morning, everything that you see in the stores, it's all because of oil. So actually,
there it is.
There it is. So like I said, everything is oil. The stool you're sitting on, the cereal breakfast you had this morning, the whole world economy is still driving on oil. 90% of all industrial processes still require oil. 95% of all transport is still based on oil and fossil fuels. So
there it is. Yeah.
Okay. 90% of the world economy is running on fossil fuels. You can make the sum if you want. So renewables are still marginal. And like I said, we owe a lot to oil. So you can see that our well-being, our wealth is actually, we can contribute oil, our wealth actually to our oil that we have discovered 100 years ago, and we still depend on this oil. We are still like making all of our stuff thanks to oil. So we need it. So if you say, okay, why drill on the North Pole? That's not that good for our climate. But no, yeah, we need it. So actually, it's a good thing that we go to the North Pole and go drilling there, or that we go to some virgin forests in Ecuador and then chop all the trees off to drill for oil. Yeah, we need it. We cannot just bypass this fact. And that's actually also not what we're claiming or selling to companies. We never say like, now we have to stop consuming oil. No, we are just highlighting the risks of continuing to consume oil, because in the future we will run out of oil. That's definite. But there's also a minor point to oil, that is climate change. And for the non-believers, this might be a funny cartoon to you. There have always been the announcers non-believers. And it's so strange that even if 13,000 or in the thousands of scientists have come up with scientific articles that have been peer-reviewed that state that climate change is real, still you have like those tens or dozens of articles that deny climate change, and they are actually put in the balance as an equal weight. So just look at the television debate. They always invite one denier and invite one climate scientist, but actually it should be the other way around. There should be like 99.99% of climate scientists and then 1% of climate deniers, because that's what we are looking at. So we are not going to argue the numbers, the facts or figures anymore. How is it caused, climate change? So we have this. We have our atmosphere. A lot of people think that it's endless. The sky is the limit. But if you take an apple, actually the peel of the apple is our. If you would take the apple as a world, and the peel, and then actually the atmosphere would be the ball actually. Then the peel of the apple would be actually our atmosphere. It's very thin. It's ridiculously thin. So to introduce the concept of global warming and how it is caused, like I said, our atmosphere is just a thin layer. So we are pumping lots of carbon dioxide in this thin layer. That's called atmosphere. And what we are actually creating is the greenhouse effect. So we are adding a blanket every time we add more and more carbon dioxide to this layer. We are adding a layer more of blankets on our Earth. So the Earth the solar radiation is coming in, but the infrared so which is actually causing warmth, it cannot go out anymore. So we are creating an imbalance. So warmth is staying in the atmosphere, which actually warms our Earth and changes our weather system. Many deniers would say, yeah, but we can see a pattern. It has always been like that. We have always been witnessing a cycle of high temperature, low temperature, and we are again on that cycle. So you can see, so the lower temperature that coincide with the ice ages. So the lower temperature are the ice ages. I can see that the cycle of temperature actually corresponds or correlates with the CO2 concentration. So high CO2 concentration, high temperature, low CO2 concentration, low temperature. And now I have to ask you a question. So you have here the last ice age, and you would say, and here. What was the temperature, the average temperature on Earth during this last ice age? If you know that the average temperature, world temperature now is 15 degrees. Just do a bad guess.
5.
5?
7.
7. Actually, you already studied this matter, because many people say, yeah, minus 50, no, minus 100. Yeah, but you're right. There was only a difference of 6 degrees. It was 9 degrees during the last ice age. And then we had like 1 kilometer of ice above our heads here in Europe. So if you know that just this is a difference of 6 degrees, where are we now? We are at 400 ppm CO2 concentration. What is ppm? For the ones who don't know, ppm stands for parts per million. So there are an awful lot of parts in the atmosphere, in the sky, and CO2 is one of them. You also have water vapor, you have also methane gas, so CO2 is also one. And of course 20% is oxygen. So just to give you an example, many people say, yeah, it will be Côte d'Azur here in Leuven, here in Brussels. So we're gonna sip, so Vercarre and under the palm trees. But just imagine that a difference of 6 degrees, minus 6 degrees, was already an ice age. What will be plus 6 degrees? It will be a nightmare. It will be hell. Just to give you some perspective. There's also a famous swimming pool builder. It's called Nassens, and he really thinks he's gonna be able to actually make more swimming pools when climate is going towards plus 6 degrees rise of Celsius. It's not like that. So how many gigatons of carbon dioxide did we already emit, and how much are we actually still allowed to emit? And this might be my most important slide. Many people don't know this, but of course you already studied the matter. So this is what we already actually emitted into our atmosphere. 1,565 gigatons. From the Industrial Revolution till 2000. Then we added 405 more gigatons. And what are we actually still allowed to emit? How did they calculate this? So we know how much there is in the atmosphere. We know how much we can emit to not surpass the 2 degrees Celsius, because we agreed actually not to surpass 2 degrees. That's actually also what the climate scientists are saying in their scientific articles. Please do not breach the tipping point of 2 degrees. So this is what we actually can still emit, 860 gigatons. And then some smart scientists have looked to the on the balance sheets of the fossil fuel companies that are running the world economy, and have looked at how much reserves they have still on their balance sheets to actually drill, explore, consume, and they have made the constatation that now they have 760 gigatons of carbon that are sitting now on their balance sheets that are already sold. So they already sold 760 gigatons. So they know that. It's, of course, it's not displayed as gigaton in their books, but they know how many barrels each fossil fuel or oil producer is going to sell, because that's with their annual reports, that's how they actually raise money from investors. So they have to put how many barrels they are going to sell. So these are the gigatons they are going to emit. And then, of course, these fossil fuel companies also go to the investors with the promise that they have still more business to do. They have still more wells to drill. So these are the remaining company reserves that still can be developed. And now there are some capital rounds going on. So these fossil fuel companies are actually going to investors, to our pension funds. Yeah, please give me money, because we have gold in the ground that we still can drill for. And as you know, 90% of the industrial processes of this world still run on oil. So you need oil. So this is being sold right now, and this is what is still in the ground and can still be developed. We have huge coal amounts still in China. So actually, we will maybe never really run out of fossil fuels before we run out of this planet. So just to give you some perspective of what we are putting ourselves into, and how our world economy is actually just intertwined with the climate issue, is that we invested all our money, and our pension funds actually also invested our money into these fossil fuel companies, which is actually a good thing, because we need this all, you see. But on the other hand, all these climate scientists are saying, okay, you're only allowed to emit 860 gigaton, but then we have 2,860, so 2,000 gigatons too much. So what are we going to do if we say to these fossil fuel companies tomorrow, no, you cannot sell one drop of oil anymore? Then okay, the world economy is going flat. So in 3 days, no more food in the stores. So, okay. I'm just going immediately to the emission inventory. So what we are doing at Futureproofed is no rocket science. So when we calculate emission inventories for cities and governments, we just do A times B. So we look at all the liters of fuel oil consumed, all the kilowatt hours of natural gas, electricity, all the kilometers that have been driven by their car fleet, and just actually multiply them with emission factors. Emission factors you can find everywhere on the internet. The most trustful are those of the IPCC, International Panel for Climate Change. And so we know for each fossil fuel how much carbon there is in there. So we know if we burn it, how much CO2 we will add to the atmosphere. And actually that's how also they calculated how much gigatons we are still allowed to emit. So we know how much fossil fuels there are, how many liters, kilowatt hour, and then you just multiply them with emission facts. So easy as that. That's the example of city of Antwerp. So they emit 3,000 kiloton per year, and the big sources are transport, so 30%, and also the households also emit a lot. And this is typically for each city in Belgium. So transport and households have the highest carbon actually emittance. Why is that? Yeah, have you seen how many cars there are in Belgium? How many traffic jams we have? So car is king in Belgium. Try to cycle in Brussels, it's a suicide. I can tell. I live here. But and also households. We have actually in Belgium, in comparison to other European countries, one of the oldest and dilapidated patrimonium of buildings. So our buildings are also very old, so very inefficient. So this is the pattern we see for each city. So more than half is transport and households. They always blame.
What was the green one? The 21%? What is that?
This is the tertiary sector. So these are the hospitals, the schools. Yeah.
Without the harbor of Antwerp.
Yeah, without the harbor. Because if we count the harbor with it, then we reach 15,000. But there's a difference, and I didn't want to go too much in detail to what we can calculate and what is not part of our emission inventory. The harbor of Antwerp is ETS, which means European Trade Scheme System. So that means that it's a business of the European Union to watch over the shoulders of these companies, and we can do nothing about it. And also the cities, they have no jurisdiction to actually do something about these companies because they are so big, they emit so much that Europe is taking care of them. And yeah, I will do it in 2 minutes. If you give me 2 minutes. So how we do it now? We lose an enormous time of money. And also a lot of time that we lose at gathering those data. So it's very archaic. So actually what we do is we have 10 sources of data and we just mail them, and then they say, okay, fine, and then they call a colleague with it, and then they just pull it out of their database, a CVS file or an Excel file. Then there's one person that we contacted that compiles these Excel files, and then they send them to me, and then I compile it again to an Excel file, and then I put it into a nice PowerPoint, in a nice PowerPoint with nice pie charts and bubble graphs. That's how it is now. So it's very slow. So now emission inventories are every 2 years. It's manual, so it's prone to mistakes. There's a high data uncertainty. We get data from utility Eandis and also Infrax, and sometimes you can see that they put the wrong data beneath the wrong company. So the data, for example, the data of the hospital in Leuven was put under Horeca, under hotel and restaurants. Why? Because they have a hotel, they have a restaurant in their hospital. Just to tell you, there's a high data uncertainty and bad data. Hard to reach people. So you send a mail. It's the time it takes to actually to get the Excel files back, and huge Excel sheets. We are now at 14,000 rows. Just to give you a sense of what we're looking at. So and we want to evolve, of course, to this big data. This is a client of ours, the home smart metering. So now you can have an itemized bill, an overview of how much each household item has consumed in your home. So it's if you want to look into it, just go to the website. Vinyam, you also know it. They want to turn each car into an IoT device that will sensor the environment and also also turn it into a Wi-Fi network, so you can have a wider Wi-Fi coverage. So this is where we are heading to, and this is actually also an area in which we are taking small baby steps, but we are we already had some clients for which we already connected some dashboards of ours with their API systems. So we are doing it, but we are seeing a whole avalanche of data coming towards us, and like I already summed up all the negative points of how we are processing the data now. it's very slow, and policy is always lagging behind. So the policy, so City of Antwerp, they have to draw future climate policies based on data and emission inventories of 2 years ago. It's unbelievable that it's still like that. And like we already heard of Jeff and Matthew, we are sitting on this mountain of data and we are doing nothing with it.
Thank you very much.
Yeah. Thank you.
We have time for one question. Leave the time for Martin to set his PC up. Any question in the room? No, you've done it already. Yeah.
Show us an emission pie chart of Antwerp. What does it look like for Beijing?
Yeah, I don't know. I should look into it, but I think that companies will take a much major part in it, as consumption is very low, I think. Like the average carbon footprint of an Indian guy is 1.2 kilos. Yeah, 1.2 tons per person per year. And for Belgium is at 12. For an American is at 20. So just to say, households are already very efficient. But
we have one more question. Anyone? At the back.
Are companies' carbon emissions openly available, or are they private?
The ones that are honest about it are available. But we see that many companies that we have guided in the past, for which we have made carbon footprints, that they actually don't disclose them publicly, which is pity, because if you're doing good, yeah, you can tell, of course, but you can also tell the less good. Just be frank about it. But yeah, that's an issue I don't want to go in. We have a whole list of anecdotes. If I can share them with you afterwards.
Ready? So thank you very much, Christophe.
Yes.
Hey, I hope you like this presentation. This presentation was held in the Brussels Data Science Community Meetup. If you want to know more of when these meetups are taking place, just check the link below. Bye-bye.